Okay. Okay. Let me have your attention, please. Let's begin. Let me have your attention. Welcome to the University of Tennessee Nuclear Engineering Department Colloquium Program. My name is Lee Dodds, and it's my privilege to introduce today's speaker, who is Mr. Jeff Gasser. Jeff is the Executive Vice President and Chief Nuclear Officer of the Southern Nuclear Company, which is headquartered in Birmingham, Alabama. Jeff received a BS in Mechanical Engineering from Georgia Tech in 1983, and that was followed by an MBA at Augusta State University in 1995. He joined the Southern Company or its predecessor in 1983, and the nuclear side of the house, and he's been there ever since, holding many different jobs, including he's a senior reactor operator. He was a shift supervisor and eventually became plant manager at the Vogtle plant, and then rising to his current position of Executive Vice President and Chief Nuclear Officer. The title of his presentation today is U.S. Nuclear Power Plant Performance and New Nuclear Plant Construction. Ladies and gentlemen, please welcome Mr. Jeff Gasser.
Thank you, Professor Dodds. Good afternoon. As Professor Dodds said, I'm from Southern Company. Southern Nuclear Operating Company is the subsidiary that operates the 3 nuclear plants in Georgia and Alabama. Plant Vogtle is over near Augusta, Georgia. Plant Hatch is near Vidalia, Georgia. And Plant Farley is near Dothan, Alabama. Farley and Vogtle are both 2-unit pressurized water reactors. Hatch is a 2-unit boiling water reactors. So 6 units that we operate. Our corporate headquarters are in Birmingham, Alabama, and there out of Birmingham we have the functions that support the 6 units, including design engineering, nuclear fuel design, human resources, financial services, those type of functions that support the operation of the 6 units. Now, what we do, our mission for Southern Company, is to safely and reliably operate these units for our owners. The Farley plant is 100% owned by Alabama Power Company. The Vogtle and Hatch plants are co-owned. The largest ownership stake is by Georgia Power Company. There's also an ownership stake with Municipal Electric Authority of Georgia, Oglethorpe Power, and the City of Dalton. What I'd like to start off with is talk to you a little bit about where U.S. nuclear plant performance is, where it's come from, and then my opinion of how we've gotten to where we are today, and how those forces are shaping the potential for new nuclear generation, both in the U.S. and worldwide going forward. We have here a chart of capacity factor for the U.S. and world plants. You can see that it started off in the low 70s back in 1991 and has reached the point where we are today with the U.S. plants approaching almost 90% capacity factor. Significant performance improvement, which has driven the megawatt output of the U.S. units to the highest levels that we've seen ever. Along with that, you see this the unplanned capability loss factor for the U.S. and worldwide. Again, steadily come down. This obviously drives the previous slide, the capacity factor. The other important factor here is an economic one. Besides driving the capacity factor and the output up, when the force loss rate is low, that means the owners, the transmission operators, when they can rely on low-cost baseload nuclear generation, then that makes their ability to market and sell their fossil and gas plants much more economical. Unplanned loss at a baseload nuclear unit has a significant negative economic impact on the owners. There you see the averaged forced outage rates, again, from the mid-80s in the about 15% range, steadily coming down to almost 2% in 2004. Again, reflective of significant improvement across the U.S. in safe, reliable, and predictable plant operation. This chart here shows the average refueling outage length worldwide for light water reactors. It specifies light water reactors because, as you probably know, there's several different technologies employed worldwide. For example, the heavy water reactors that are in use mainly in Canada, they perform refueling operations online. So to try to get a good comparison, we compare light water reactor technology. You see here the steady decrease worldwide in refueling outage duration. This has been driven by many factors. One of the more significant factors has been the regulations and the regulatory environment with the Nuclear Regulatory Commission in the U.S. that I'll talk about a little bit later on in my presentation. You see over here, you see an increase in Asia. That's mainly been due to issues that have occurred in the Japanese fleet associated with some materials issues that have resulted in longer refueling outage for inspection activities. Now you see the average in the U.S. is about 40 days. Many plants in the U.S. are routinely performing refueling and maintenance outages in the high teens to low 20-day range. It's a great accomplishment. It's really phenomenal to see the work that gets done. The planning for refueling outage to be executed in 18, 20, 22 days is really spectacular. If you can imagine thousands of surveillance tests, inspection activities, corrective and preventive maintenance work orders, the planning that goes into that 18 months ahead of time, leading up to the actual day the outage starts, tearing apart large pieces of equipment like turbines and pumps, performing inspections and repairs, getting everything back together again, and starting the plant up is a great effort, and it's really a phenomenal thing to see when you're at the plant during a refueling outage. For any of you that co-op or intern with the utility that has nuclear units, I really encourage you to try to take the time to be there, spend time at one of those units when they're in a refueling outage. Here you see the trend in uprates of the U.S. nuclear fleet. Most units, when they were originally designed and constructed, had significant margin left in their nuclear output. That is, significant safety margins that were built in that allowed for increasing the reactor power and the electrical output of the units. If you remember, around this time frame in the early 90s, the common wisdom in the nuclear industry was that the only growth component in the nuclear industry was in the decommissioning business. And almost all the talk was about decommissioning and how that was the trend for nuclear units, and that very few nuclear units were going to actually operate till the end of their licensed life. And a number of factors came together that really turned that equation around. And what you saw was very few units shut down early. And in fact, as this reflects, most nuclear units have have gone through the process of applying to the Nuclear Regulatory Commission to actually increase their licensed output, and that's shown there with, you see this point here, we had about 500 megawatts of increase from uprates, and we're now approaching 4,500 megawatts. So in just over 12, 13, 14 years, you've seen approximately 4,000 megawatts added to the grid just in uprates of existing U.S. reactors. This shows the production costs of various fuel sources in the U.S. fleet. Here in the 80s, post 3 Mile Island, nuclear was significantly more expensive than coal. Over that time, nuclear has now come down to where it is. It is the most cost-effective electricity generation source. You see, what that reflects is in the oil and gas market, there is significant price instability. Over the last 7 to 10 years, almost all the generation that has been built in the U.S. has been natural gas fired, and what we're seeing in the industry is significant volatility in natural gas prices, and you compare that to coal and nuclear, which have relatively stable prices, and the economics are fairly obvious there that going forward, what customers want, what the owners want, is a predictable economic situation. That's what makes nuclear really an optimum fuel of choice. Most U.S. plants were originally licensed for a 40-year lifetime, and plants have the ability to apply to the Nuclear Regulatory Commission to get an extension on that life of additional 20 years for an operating life of 60 years. Most plants have either gone through that process or are going through or stated the intent of going through that process. In my prediction of the 103 operating reactors in the U.S., I believe a large majority of them will eventually have their license extended to 60 years. I believe there'll be just a very few number that decide not to extend their license to 60 years. You see here already there's been 30 license applications granted. 16 are currently under review from the Nuclear Regulatory Commission. An additional 22 reactors have stated their intention of applying. At Southern Nuclear, we have received a license extension for the 2 Hatch units, so they are now licensed to operate into the late 2030s. We currently have, under review by the Nuclear Regulatory Commission, the license extension application for the Farley units. We expect to receive approval for that license extension by July of this year, and we are beginning work on license extension for the Vogtle units. So at Southern Nuclear, we plan on operating our units well into the middle of this century. What this reflects is the huge impact on our nation's generation supply by license extension. The green area represents the capacity of the U.S. nuclear fleet under their original license durations. The blue area represents the additional generation that will be available, assuming 100% license extension. As you know, designing and licensing, building, and starting up the next generation of nuclear units is not something that is just going to happen in the next 2 or 3 or 5 years. It's a long process for very good reasons. Detailed review both by the design firms, by the Nuclear Regulatory Commission, and of course construction is going to take a few years. So the ability to put large baseload new nuclear generation in the ground and have it operating is something you just can't do overnight. I think the significant thing this reflects is that if license extension didn't happen, we'd be facing a significant shortfall in generation due to nuclear units shutting down, reaching their end of their license life in the 2010-2015 time frame. And what license extension does is extend that out into the 2035-2040 time frame, which gives us time to go through the process of planning and building and installing the new baseload capacity we're going to need in this country in order to meet our energy demands of the future. So license extension, license renewal is having a significant positive impact on the security of our U.S. energy supply. What this reflects is the avoided CO2 emissions that we're going to realize due to U.S. nuclear plant license extension. So clearly, significant benefit environmentally that's recognized by continuing operating the U.S. nuclear fleet beyond the original license. Now, what that really shows, all those factors, what that demonstrates is that nuclear power is a safe and it's a reliable, it's an economically friendly, and it's a low-cost solution to meeting our country's energy needs going forward. Well, why did all that happen? You look at performance from the mid-'80s, early '90s, and you look at where U.S. nuclear performance is today, and what happened? What factors, what forces came together to cause that kind of significant improvement? And I don't believe improvement like that just happens. It really takes a concerted effort by numerous people and groups for it to happen. In the commercial nuclear industry, I think there were three basic factors that caused that kind of significant performance improvement. The first is the Institute of Nuclear Power Operations, or INPO. INPO is an industry organization. They were founded shortly after the 3 Mile Island accident in 1979, and INPO's mission is to promote the highest levels of safety and reliability in the U.S. nuclear fleet. And they have been the single most significant factor in driving safe, reliable plant performance improvement since the beginning of the 1980s. It's really significant to understand INPO's role because I don't believe any other industry has an organization like INPO. I don't know of any other industry that cooperates like the U.S. nuclear industry cooperates. One of the cornerstones of INPO's mission is in the fast sharing and dissemination of operating experience among the U.S. nuclear fleet. So when something happens at one plant, in a very quick fashion, the detailed technical information of what happened, the root causes, what that operator is doing to correct it, is disseminated to all of the U.S. fleet, so that everyone can learn from that experience, and everyone can improve from that without each individual operator having to go through that pain. Another cornerstone of INPO's mission is in the training area. Part of INPO is a group called the National Academy of Nuclear Training, and what they do is they accredit the training programs at all of the U.S. nuclear plants. So everyone that's an operator, engineers, mechanical maintenance, electrical maintenance, instrumentation, health physics, chemistry technicians, all of them are trained and qualified under accredited training programs through the National Academy of Nuclear Training. So the standards that you see at a nuclear plant are consistent, and they're consistently high. One of the ways INPO accomplishes their mission of promoting the highest levels of safety and reliability is through plant evaluations. And again, this is something that I'm not aware that any other industry subjects itself to, but it's a key driver for the performance improvement we've seen. Every U.S. nuclear plant receives an INPO evaluation approximately every 24 months. Now, what this involves is putting together a fairly large team of people from the industry. That a team is usually around 24 to 28 people, and these are our peers. They represent all the different areas of plant operations, from engineering to operations, maintenance, chemistry, health, physics. And that team comes on your site for 2 weeks, and they examine every aspect of your operations. And out of that, they write a report that identifies your greatest strengths and your greatest areas for improvement. And from that, each plant takes that and uses that to drive performance improvement at their station over the next 2 years until the next evaluation team comes back and goes through that process again. And again, I don't know of any other industry that subjects itself to that kind of examination, that kind of peer review. But getting that kind of peer review, that kind of sharing of information and experience has been the single most significant driver for the performance improvement that we've seen in the U.S. nuclear fleet. The second reason for the improved performance is the Nuclear Regulatory Commission. In approximately 2000-2001 time frame, the NRC revised their oversight process of the U.S. nuclear plants. The old process was a very deterministic one. There's the regulations that are laid out in the Code of Federal Regulations. There are inspectors, resident inspectors that work at each of the sites, plus inspectors that would come to the sites from the various regional offices, and they would inspect the plant against the regulations, and based on those inspection findings, they would identify violations of regulations, and the plants would respond to that. That meant that the regulatory process had a couple of shortcomings. While it worked, a few shortcomings were that it wasn't real predictable. And a second shortcoming was that it wasn't very transparent to the public, for the public to understand how plants were being operated safely and how the NRC was regulating plants to ensure their safe operation. In 2001, the NRC revised that process, and a significant aspect of that was the introduction of performance indicators. And these performance indicators are objective measures in key cornerstones of nuclear safety. They include everything from performance of key safety systems in the plants to radiological safety, nuclear security performance indicators. And these performance indicators are based on probabilistic risk analysis, and they are available publicly through the NRC's webpage, so any member of the public has the ability to look at the current performance indicators of any U.S. nuclear plant and have an understanding of where that plant stands and how they're performing against those indicators. Another significant change that the NRC undertook was basing more of their regulatory process on probabilistic risk assessment. It has allowed licensees to focus our resources and our efforts on those things that truly improve nuclear safety and have the largest impact on nuclear safety. The NRC has demonstrated their ability to effectively work through licensing issues. I mentioned earlier the license renewal, license extension process. That is a great example of where the NRC laid out a defined process. They set expectations internally to how the license application review process should work. They set expectations for us, the licensees, on what our license submittal packages should contain technically, and they have demonstrated over the last several years great accountability in doing a thorough review and approval of the license renewal process. And lastly, the third major factor that's driven our performance improvement has been industry consolidation. Over the last 10 or 15 years, there's been significant consolidation of nuclear plant operators in the industry. 15, 20 years ago, there were numerous companies that were operating a single nuclear unit. Now there is only a handful. I believe that over the next 5 to 10 years, there will be very, very few, if any, operators of a single nuclear unit. What you see now is companies like Exelon, who are operating, I believe, 18 or 19 units. You see Florida Power and Light, purchasing the Seabrook plant in New Hampshire. You see Progress Energy, or what used to be Carolina Power and Light, merging with Florida Power Corporation to form Progress, and now operating the three plants in the Carolinas, plus now the Crystal River plant in Florida. In my own company, we used to operate separately. The Farley plant in Alabama was operated by Alabama Power Company. The two plants in Georgia were operated by Georgia Power Company. And we've since formed Southern Nuclear, merged the nuclear operations so that now we're operating the 3 plants, 6 units as a fleet. And what that's done is it's significantly driven higher standards of performance. It's taken the lower performing plants in the country and brought their standards of performance up to be more equal with the average performance in the country. It's caused there to be a significant improvement in the management abilities at the companies that are operating these units. So this consolidation has been a significant factor in our overall performance improvement. I take a lot of satisfaction in working in the industry I work in. It's my belief that universal access to low-cost electricity is one of the foundations for the standard of living that we have in this country. So being a part of that, being a part of a company that provides electricity safely, reliably, and economically, I think is a great thing to be a part of. The IEA World Energy Outlook report in 2002 said that a quarter of the world's population, 1.6 billion people, do not have access to electricity. And in the absence of any initiative to make that change, by 2030, 1.4 billion people will still lack access to electricity. So when you look out and ask yourself, what is going to happen, what is the status of nuclear in the future, and you look at worldwide the incredible need for electricity, particularly in countries with lower standards of living, it's obvious that something has to be done to be able to provide access to large amounts of electricity worldwide. Also, the second quote there, a lack of electricity and heavy reliance on traditional biomass are hallmarks of poverty. So going forward, both here in the U.S. and worldwide, being able to economically, safely, and reliably produce large amounts of baseload electricity are going to be important to the world. When you look at the global picture for U.S. generation, you see a pretty surprising story. A lot of people don't realize this, but there are currently between 20 and 25 reactors under construction worldwide. While there are no reactors under construction in the U.S., you see right here, this is the U.S.'s share. Approximately 20% of our electricity is currently derived from nuclear. Over here you see China. 2% of China's electricity is currently produced via nuclear. China currently has 2 reactors under construction, and it's their intentions to build between 20 and 25 reactors over the next 20 years. Over here you see Lithuania derives 80% of their electricity from nuclear power generation. France, 78%. South Korea currently derives 40%. Korea has a significant nuclear construction program in progress right now, and they have a national energy policy with plans of achieving energy independence, and nuclear is a cornerstone of that policy. So you see, going forward, the worldwide share of nuclear generation is fairly significant, and many countries are actively involved in increasing the percentage of electricity that they get from nuclear. This graph is the forecast for worldwide energy demand. Again, you can see the purple line here. That is Asia. A significant amount of that growth being fueled by China. You see steady demand worldwide, steady projections for the increase in electricity demand worldwide. And conservation is a great thing, but conservation will not meet the energy demands of a growing population and the growing economy. The facts are that people around the world are going to continue to use more electricity, particularly as standards of living continue to increase, and somebody's got to be able to provide that electricity, and it has to be provided in an economically friendly way, it has to be provided in a safe way, and it has to be provided at a low cost. Just China alone, you see the growth in electricity demand in China, 10% plus growth demands, and those are forecast to continue out for the next several years. This chart here, this shows the anticipated global demand for new nuclear capacity worldwide. And the yellow bar shows the left scale here is gigawatts. If you just assume that the average nuclear plant is 1,000 megawatts, that's 1 gigawatt. So the yellow number shows the current gigawatt capacity for each country. The blue bar is the expected new nuclear capacity demand between now and 2050, and that's the low estimate. The red bar is the high estimate of expected nuclear demand. Now keep in mind, this isn't just for total electricity growth demand. This is assuming that nuclear is just one piece of a diversified fuel mix worldwide. So much of the worldwide growth in electricity demand will continue to be met by coal, oil, and gas, with nuclear being just one piece of that diversified fuel mix. But you see here in the U.S., the low estimate, 286 gigawatts. That's 286 new 1,000 megawatt nuclear plants between now and 2050. China, of course, with their high growth, the low estimate of 100. So you see worldwide a huge expected demand for new nuclear capacity going forward. Basically, the great news for you, for anyone that's in the nuclear business, is that the future of nuclear power is here today. It's an exciting time to be in the nuclear business. People need a reliable source of electricity to continue to grow their standard of living. The evidence is clear that nuclear power offers a safe, reliable, cost-effective, and environmentally form of electricity. And you see in the U.S. political leaders being more open and more friendly to the idea of new nuclear plants going forward. If you saw the President's State of the Union address, he specifically mentioned the need for new nuclear power going forward. So it's a great time to be positioned in the nuclear power industry. That takes me to where are we today with new nuclear generation? For those of you that might have been here 2 weeks ago, a colleague of mine, Gene Graycheck from Dominion, he was here and he talked about Dominion and their status of where they are in new nuclear generation. I believe he mentioned New Start. New Start Energy Development is a consortium that was formed in 2004, and it comprises of the utilities that you see listed there. In addition, it's got Tennessee Valley Authority will be providing in-kind engineering services as part of the consortium, and it has 2 nuclear plant designers, General Electric and Westinghouse. The purpose of New Start is to test the combined construction and operating licensing process of the Nuclear Regulatory Commission. Also, the purpose is to bring to completion design certification for 2 types of reactors, the Westinghouse AP1000 and the General Electric Economic Simplified Boiling Water Reactor. New Start was notified in November that we were a recipient of a DOE Nuclear Power 2010 grant. There's active negotiations with DOE to finalize that by the end of this month. Initial funding is at $4.1 million, and the Phase 1, the 2005 project deliverables include selecting a site that would be used as part of the combined operating license application, continuing with the AP1000 certification schedule, and completing and submitting to the NRC the General Electric ESBWR certification application. And then finally developing a uranium agreement and developing a detailed schedule for Phase 2, which would include the schedule for actually applying to the NRC for a combined operating license. Now, one of the things that's important to the industry, we think going forward, that it's important to have 2 reactor designs. We think that as an industry, we believe that both General Electric and Westinghouse have very viable designs, and having an option to choose from and having competition is in the best interest of the electric utilities. Well, the idea of new nuclear is not without its challenges. There are still significant hurdles to be overcome before anyone is going to actually commit to building a new nuclear plant. The first is that the projections for the need for new baseload capacity have to bear out. Without the demand for new baseload capacity, there wouldn't be a need for a new nuclear plant. The resolution of the spent fuel issue is key to our success. Yucca Mountain is important to the success of new nuclear and the current fleet of operating plants. So having the Department of Energy fulfill their obligations under the law to complete and license Yucca Mountain as the permanent repository for spent nuclear fuel is important to the industry. Regulatory unpredictability is one of the challenges. I mentioned earlier the NRC has demonstrated the ability to perform the reviews of the license renewal applications in a predictable schedule, but the process for receiving a combined construction and operating license has never been tested. All of the current operating fleet in the U.S. was licensed under the old licensing process, in which a plant first received a construction license to build a unit, And then after it was built, after billions of dollars were spent and invested, then you came back and applied for an operating license to operate the unit. And of course, no one's going to take that kind of financial risk anymore. In the early 90s, the NRC revised that process to be a one-step licensing process where up front you apply for and receive a license to both build and operate the unit. And then the NRC inspects to ensure that the unit is built to the proper specifications, and then when it's finished, you are licensed to go into operation. So being able to demonstrate and prove that that process works and is predictable is important to the success of a new nuclear plant. A lack of complete advanced designs. The AP1000 design certification has been received from the NRC. The GE ESBWR has not been certified yet. Completing that is important. Also, there is still significant first-of-a-kind engineering that is required for both these units, and first-of-a-kind engineering costs are expensive. So being able to complete those in an economic manner is a big challenge. Public confidence is important. When I talk with employees, everyone is excited about the prospect of new nuclear. When you see polls, public opinion polls, you see very strong public support for nuclear power going forward. But what I tell our employees is that they play a significant role in the decision in the future to build new nuclear, because it will remain an option only as long as we continue to operate our existing fleet safely and reliably. If there is a significant safety incident or accident at any U.S. nuclear plant or any plant worldwide, that would be a significant obstacle, significant barrier to the decision to go forward with building a new nuclear unit. Reestablishment of the nuclear infrastructure. As you can imagine, as many of you have probably seen, everything from the ability of the NRC to license plants, the infrastructure of schools and universities across the country for teaching nuclear engineering. A lot of that went in decline with the nuclear industry in the 80s and early 90s. We're seeing a resurgence. We're seeing increased enrollment in nuclear engineering programs across the country. But building that infrastructure, both from an educational standpoint, from a government regulatory standpoint, and a supplier standpoint, is a big challenge for the industry. And finally, demonstrating that we can achieve acceptable financial returns. The fact is generating electricity is a business, and we rely on investors to fund our business, to underwrite our business, and they will only invest their money if they believe they will get an acceptable return at an acceptable risk. So being able to demonstrate that we can deliver that return is a big challenge before we can begin building new nuclear. This gives you a little bit of idea of the benefits of actually embarking on a standard fleet construction program for new nuclear. This data basically comes from the South Korean fleet. You see here the first plant, from first concrete being poured to commercial operation, 64 months. Gradually reduced to now the fifth plant, expects to be have that first concrete to commercial operation take only 54 months. So being able to demonstrate that kind of predictable and improving construction schedule is important, and you're only going to achieve that through a standard design approach. Also, on costs, when you achieve that kind of predictable construction schedule, then the costs naturally follow. And this is the data from the South Korean fleet, and you see significant synergies associated with the follow-on plants following the first plant that's built. Before I take some questions, what I'd like to point out is that it's a great time to be in the nuclear business. everyone from the designers like General Electric and Westinghouse, to the Nuclear Regulatory Commission, to us, the owners and operators of nuclear plants. We are looking for talent. We are looking for people that want to come work in our business and help us succeed. You can see going forward, it is great prospects for the nuclear industry, and I just encourage all of y'all to talk to people that that might not know what they want to do. Talk them into a great career in the nuclear industry. I can't imagine working in an environment that is safer, that is more professional, and more gratifying than working in the nuclear power industry. And with that, Professor Dodd, I'll be glad to take some questions.
Okay, we have time for questions and comments. Okay, Bill?
Does the info database include information from overseas nuclear, such as EDF or Korean?
The info database? The data that I showed you did not. However, following the Chernobyl accident in 1987, the World Association of Nuclear Operators, which is affiliated with INPO, was formed, and most non-U.S. plants are members of the World Association of Nuclear Operators, and so there is a great deal of information that's available from the non-U.S. plants.
Mario?
If the 475 plants, is there enough uranium to go around? Will you have to go to fuel recycle? And how many come out do we need, or do we have on-site fuel cycle?
Okay. First of all, for the projection of new plant construction that's needed, the supply of uranium, there is a large worldwide supply of uranium. Not all of the identified deposits have mines currently built at them. It has been an issue recently. In the past year, we've seen uranium prices double approximately. We expect to see that demand to continue to increase. And it is one of the challenges, managing that fuel cycle from getting the uranium out of the ground all the way through to the enrichment and processing and fabrication is a challenge for the industry going forward. And we need to make sure that we're preparing for that now to meet that demand. But worldwide, there is sufficient uranium deposits to meet all the needs going forward for a long time.
So you probably won't need a fuel recycling.
Right now, I don't believe we're going to need to go to fuel recycling to meet those needs. Due to the large deposits that are available worldwide.
You don't think you need waste treatment or anything like that? Transmutation or something like that.
Well, that's a great policy question. There's a lot of benefits to waste processing from a reduction standpoint. That's something that's a little bit beyond my knowledge and experience, mainly due to the longstanding U.S. policy of not reprocessing.
Yes.
Kind of a two-part question, not 4 parts, but only 2. First part is you're speaking to a lot of graduate students, masters and PhDs. Do you see that there's going to be a demand for masters and PhDs at utilities?
At utilities, I see that there will continue to be a demand for masters at utilities. For PhDs, the kind of work that we do rarely requires that level of education and training. I do believe there'll continue to be a demand for PhDs as the nuclear engineering programs across the country continue to see increases in enrollment and expansion of research, particularly on the next generation of nuclear plants. What I talked about was, I talked about the generation that currently is under design, the AP1000, the GE ESBWR. But then when you go beyond that to the next generation, when you're looking at plants that can not only supply electricity but also hydrogen for the hydrogen economy that you've heard this administration talk about as to replace or substitute for fossil fuels. I believe there'll be a continued strong demand for PhDs to support that effort.
Kind of going into my second question then, and I'm glad you mentioned research. Some of the recent executives that have spoken have basically said that they need to see a direct payback from research expenditures because of these financial considerations, and you're using shareholders' money. That seems kind of be short-sighted and not look. It seems short-sighted because you have to be competitive, 10 years out, 20 years out. I think we're lucky that we have DOE putting some research money in. But two, if you're expecting to hire master's students, we have to train those. You have to have research to get them through the university in the first place. What's your perspective on utilities funding research?
Well, I think there is a place for it. Southern Company and Southern Nuclear, we do provide funding for research activity and at educational institutions. There's obviously a balance that has to take place because we are a for-profit organization. A lot of the research that you're talking about, I think, is the kind of thing that is really, it's not for the benefit of one organization. It's for the greater good. It's in the national interest, and that kind of research funding, I believe, is really best funded at a national level through Department of Energy or other organizations like that. But at Southern Company, we do provide funding for graduate level programs.
We have another question. You can think. Okay.
I have one question regarding the increases in capacity factor. Has anyone provided any math to say what the extended fuel cycles contributed to those added capacity factors? Year and a half, 2-year fuel cycle.
I'm sure somebody has. I don't have that data. I'm not familiar with that at the top of my head here. But that has been a driver. You take a plant that refuels every 18 months, like for example our hatch units used to be on an 18-month cycle, and you extend that to every 2 years, and we are seeing the positive benefits of that extended fuel cycle.
The amount of reading I had done up to now is the outages on a 1.5-year cycle or a 2-year cycle are not substantially longer than a 1-year cycle.
That's correct.
So you're talking a 30-day, 40-day outage once every 1.5 to 2 years versus one every year. Obviously, we're going to get a substantial gain from that.
That's correct. That has been a contributor.
On availability and unreliability in your equipment in the process.
Yeah, that's right. That has been one of the positive drivers for the capacity factor increases.
We do have a question. As many of you know, we do webcast these presentations, and so we have the opportunity for people in cyberspace to ask questions. They do that by sending an email during the presentation or before the presentation, and then it's printed off and handed to me. And this question comes from a person most of us know. He was the speaker last week in the colloquium. His name is Tony Buell, and it's a very good question. What are the most likely safety issues that may curtail nuclear power output in the next 5 to 10 years in the USA, and what is the industry doing to predict those problems?
Okay, great question. Probably the most likely situation that could curtail U.S. nuclear power output would be materials issues. Materials issues are something that we don't have a large experience base on. As the current fleet reaches the age that it's at, and we don't have a lot of past experience to base the future on. So first, funding the research that the industry is funding a significant amount of research in the area of materials and how materials act, and being able to stay ahead of that and continue to manage our fleet so that materials issues don't cause extended shutdowns for component replacement is one of the bigger challenges currently facing the fleet.
Okay, you can probably expect to get a proposal on doing research from one of our materials experts in this department because of that answer. Thank
All
you
right.
for that answer. Do we have any more questions?
By the way, I'll go ahead and throw in one more
Okay.
thing there, is that we have a hard time finding materials people. Materials engineers are difficult to come by, so it's a great field to be in.
Okay.
I believe, Southern Company has recently received an early site permit for building a new reactor. What's the timetable for you guys and the next few steps that y'all are going to take in that process? And who do you see sharing like the financial burden of eventually building a reactor? You see being like an Alabama Power and a Dothan, or and for a Poly plant, or like Georgia Power and a bunch of other people coming together?
Okay. Well, first off, we have not received an early site permit. What we have done is we filed a letter of intent with the Nuclear Regulatory Commission to inform them that we plan on submitting an early site permit in mid-2006. That allows them to plan their resources to be available to review that early site permit when we file it. So we are just now gearing up the effort to begin working on that early site permit. Right now, that is not a commitment to actually build a new nuclear unit, but it does get out of the way a couple years worth of work that goes into the early site permitting process that keeps nuclear as an option going forward. So we have not yet selected a site, so we really haven't gotten to the point of making decisions on financial partners and those kinds of things.
Okay. Before we adjourn, it turns out that we have several students in our department who either co-op or intern with the Southern Company, and it's been a very good experience for those students. And we have a few of those students here today. So, Gary, if you'll turn the camera back on the audience, I want the students who have either co-op or interned with the Southern Company to please stand up. Why don't we do that? Stand up. That way Gary can get you. Okay. Thought we had one more in the back. Not all of them are here today. Thank you very much.
Well, you have to give me the names of the ones that didn't come to hear me speak.
We do have at least one new face in the audience today, and everybody else knows that after each one of our colloquium presentations, we have a party downstairs. It's a reception where everyone is invited, all the attendees, and we even get a few students walking in and partaking of the refreshments who did not show up for the presentation. Okay, I usually corner those and have a little discussion with them, but we welcome everybody. But before we adjourn, let's express our appreciation again to Jeff for his presentation.
Oh, before you all leave, we're always looking for co-ops and summer interns to work in our plant. Hey, nice to meet you.